Hello everyone and welcome to today's tutorial, and in this one we're going to be creating loading animations for your Flutter application. And before I start, I want to make mention that this tutorial is heavily inspired by an article written on fedev.io. So most the foundation of what we're going to be working was inspired by this article. So I already have a basic boilerplate for the application we're going to be creating. So it's just a very basic boilerplate. So we have an actor and a loading animation widget. The actor widget is simply these circles you have over here. So you can see it's just a container widget with a decoration of a box shape of a circle. So that is just what we have here currently. So this is an actor, this is an actor. I gave the widget a name actor because I want they would be acting on the animations which we'll be creating later on. Initially, I wanted to give it something like a ball or a circle or something like that. But since we're going to be changing the animation shapes to create different variations, I just gave it a generic name, actor. Then the second widget is the main widget where we're going to be doing the whole animations and every other thing. So it's a class, a stateful widget called loading animation. And inside this loading animation, we declared a state member called number of actors, which is 4. And you can see we have 4 actors over here, which is just 4 circles. And in its build method, we have the row and we arrange them horizontally. So you can see over here, list that generates how many items should we generate, which is this, which is 4. And we also have the generator function, which just simply generates the individual actors. So that's the basic boilerplate of the application we're going to be building, or the loading animation we're going to be building. So you can see over here what we intend achieving in the first phase of this animation, because the first phase of this animation might not be the most fantastic loading animation, but it's going to build we're going to be building up from it. So I'm just going to do a very basic one first of all, and you'd see how everything is going to scale up. So the first thing I want to achieve over here would be to create kind of like a wave-like animation, kind of like a snake movement. So when this first actor moves up, the second one moves, and kind of like something giving you this what shape would I use? Yeah, giving you the snake-like feel. So this ball goes up first, followed by this, and while this one is going up, the first one is coming down. I ought to have recorded a GIF, but we'll just progress. So let me just show you what I mean, basically. So I wrapped the actor inside the transform widget with the translate constructor. So for instance, if I do a translate, because this offset simply means the first parameter is the x-axis, the second one is the y-axis. So the y-axis moves positively from top to bottom. So if I want to move these actors up, I'm going to be doing it in a negative y-axis. So if I do minus 50 over here and I save, can you see they moved up on the negative y-axis? But I don't want to do that. What I intend achieving from this animation is to animate them based on their indices. So if I'm in the first index, I want to kind of like start that animation first before I do the second one. So to do a basic, to just show you what I mean, I'm just going to do something quickly over here. So I'll now do return. So if it's the first index, watch what happens. If the index is equals to 0, okay, so I'm supposed to do a hot restart. Okay, I'm not supposed to do a hot restart. I was supposed to change this for us to see the changes. So you can see what happens here. If the index is equals to 0, what should you do? Offset this first actor by a negative 50 pixels. So how I intend this animation should go would be, once this guy is going up, the second one should go up, and when you get to the last one, this first guy should be down. So it's going to be giving us a snake-like effect, something like kind of like a wavy effect. So that is just um, basically what I want to achieve. So we won't be doing it this manual way. We're going to be using animations. We're going to be using animated Buda and animation controller to actually set this animation. So let me just quickly do something. Let me just check. Okay, let's just leave this for now and continue. So the stuff I want to be doing right now would be to set up my animation. So we already get we already have a basic feel of what I intend achieving. So when the first ball offsets, I want to kind of like put individual offsets in between individual actors. So I'll just undo everything we've done over here and would save. So the first thing I would want to do would be to start creating my animation. But before we do that, I want to be able to just create a few more variables over here. So I'm going to be doing double so the initial offsets, I want that to be 0, and the final offset, I want that to be, let's say, 1. And we're gonna you're gonna have a good understanding of why I'm setting these variables, because I'm gonna be multiplying these initial offsets by the final offset. So we'll just keep going. Then the next thing I'm gonna be doing would be to create an animation controller, and I'm gonna be naming it loading animation controller, and inside would have the init method, and over here we're going to be doing something. We'll just do this loading animation controller dot forward. So whenever the widget mounts, it should start playing the animation. So whenever this loading animation widget mounts, it should start playing the animation. And the second thing would also do would be to call the dispose method to do what? To dispose of the controller. So we'll be calling it before the final dispose. So I'll do loading animation controller dot dispose. Cool. Then now the next thing we want to do would be we need to set up kind of like a function, a method in this particular class that would be in charge of looping through our animation. So when the first cycle of our animation completes, it should restart the animation all over again, kind of like to create an infinite loop of the animation. So to do that, I'll just set up a very simple function over here, and it's going to be, I'll make that private. Init loading animation controller. Let me just do init. Okay, let me name it init animation controller. So what I'm going to be doing here would be very, very simple. So I'm just going to take I'm going to initialize the loading animation controller to be this animation controller. Then I'll pass in the parameters. So the first parameter I'm going to be passing in would be the vsync, but this would generate an error because it needs to be in a ticker environment. So what I'm going to be doing would be to make this class to add the single ticker provider state mixing. So the vsync, this is going to be referring to this ticker, so the animation can be able to work as required. So the next parameter I'm going to be passing would be the duration, and the duration is going to be just 1 millisecond. So that's going to be 1000 milliseconds. So that's going to be 1 second. Cool. So we have set this up, and I think this is okay. Yeah. So the next thing we're going to be doing after this is, so the basic prerequisite to follow in this video is for you to have just a basic knowledge of animations in Flutter, because I won't be explaining every single thing. Like, you ought to know what an animation controller is before watching this video, but if you don't know, it just simply controls the animation. So cool. Then the next thing I want to do would be to add a status listener to just check the status of the animation. So it's going to be animation status cool. So this listener, so the I don't know what they call this, I've forgotten what they call this operator, but the reason I'm actually doing this chaining is, instead of me doing something like this, instead of me doing loading animation controller dot add status listener like this, I'm actually just attaching it to the instance of this animation controller to call it directly, instead of adding this additional boilerplate code. I've forgotten the name of this construct in that, but that is just exactly what I am doing. So the status listener is going to be checking the status. It's going to be called whenever the status of the animation changes. So there are multiple status. An animation has multiple status. So I just want to check if the status is equals to animation. Can you see the different types of status? We have completed, dismissed, forward, or reversed. So if it is completed, we want to do something. So if animation status is completed, I want to do what I want to call loading animation controller dot forward. So this is going to kind of like play the animation once it gets to the end. So once the first cycle of the animation is complete over here, so if the animation status is completed, then what should you do? Play it all over again. So I'm going to be doing I'm going to be calling this in the init state method. So I'll call init loading animation controller. Cool. So a brief recap of what we've done so far. So over here, we just played the animation on the first mount of the widget. Then we also executed this function so that when it gets to when the animation completes, it should restart it all over again. And in our dispose method, I'm actually doing some housekeeping here to dispose our animation controller to prevent memory leaks. So this should not be, this should be straightforward if you know your basic animations in Flutter. So the next thing I'm going to be doing would be to head over to the build method and make use of this animation, the loading animation controller. So inside our generate actors, what I'm going to be doing would be to first of all create an animation. To create an animation, so our animation would be init loading animation, and this is a method. This is a function I'm still going to create. So I'll just create that quickly. Or let me just, I'll just create that quickly. Let me just do this for now. Okay, it's gonna give us an error. Okay, so I'll just create a placeholder for it quickly, then I'll come back. Okay, before we actually do that, let me comment this out. Let me comment this out. So the next thing I'm going to be doing quickly will be to wrap this transform widget inside an animated builder. So I hope this doesn't waste my time right now. So wrap with a new widget, and it's going to be an animated builder. It's going to complain about a method, so I'll pass in the builder method, and I explain why we're actually using an animated builder in this sense. So can you see it needs two required arguments? It needs animation and builder. So let's pass the animation first, and the second thing it needs is a builder method, and I'll explain why we're using an animated builder very soon. So cool. So let me take this up, and so for the animated builder, let's see, we're going to be returning this over here. So I'll cut this out and do this, and for the child I'll pass in the child. So let's see the errors. Expected to find okay, so for the child I'm going to be passing in the child from this builder over here. Then over here I'll pass in the actor. So I will explain everything I'm doing in a minute. So yes, so what an animated builder does is that previously, if you've done Flutter animations, you could use something like an animated widget. But the disadvantage of using an animated widget is that it is coupled with the widgets in which you are building. So for instance, if you want to change the animation in that widget that extends an animated widget, you would have to go into that widget and make some changes. But with an animated builder, the widget we want to animate, which is this actor, does not really have to know about the animation. Even the animated builder does not even really have to know much about the widget. So what an animation builder just does is that it takes an animation and it updates the widgets accordingly. That means it's an animated builder is very good with transitions, so it knows when to build the widget. It knows when to change the value of the widget. So from here, because we're using an animated builder, it is going to be responsible to know when to actually change the value of this transform, because over here we are doing transform.translate. So the animated builder would be able to know when to pass the value and call set state. So with animated builder, you don't have to call set state manually. Animated builders are very good with transitioning elements and changing values accordingly. So this actor over here, you can see this actor over here. Can you see it's just a plain class? It does not, you don't do actor extends animated widgets. You just make it a plain stateless class, then you wrap it inside what an animated builder, then pass the animation you want to actually play. So remember, this animation is from this animation controller. We are still going to set everything up. And one thing to note, an animation controller progresses from or is within the range of 0.0 to 1.0. So the value of an animation would always be in the range of 0.0 to 1.0. Then you could use that value and offset whatever you want to offset for your animation. As we progress, you'd see how all this comes into play. So now the animated builder requires two arguments or two parameters, the animation and the builder. So now we've passed the builder. The animated builder, if you watched my previous video on Flutter interviews, you would know what a builder actually does. So a builder is going to be, this function would only be called when it needs to be called. So it is going to be called only when the value in the animation changes. So this builder would never be called again. So when the value in the animation changes, this widget over here updates accordingly. So that's just the basic concept of the builder terminology. If you missed the last video on Flutter technical interviews, you could watch it to get an understanding of what we are actually doing here. And one thing to also note, you can see this transform the translate. The child now, the child we are passing is the child from this builder. So it is the builder function that is going to be responsible for calling the child, for creating the child. So it would only create the new child with this transform widget when the child over here changes, and the child would only change when the animation controller's value changes. So the third argument over here is now the actual child we want to build. So we pass in the widget, which is the actor widget. So the next thing we're going to be doing right now would be to create this function over here. We want to create a function that returns an animation. We could manually do it over here in this method, but we're going to be separating our concerns because I don't want to make this method unnecessarily bulky. So I'm going to be creating a method over here that returns an animation. Then we'll be able to call it here and pass it to this animation parameter for our animated builder. So I'm going to be creating the function here. It's going to be a simple function. So the animation of type double, remember what I told you, it scales from 0.0 to 1.0. So I want to return an animation of type double, and the name of this animation function would be init loading animation. And remember what I told you earlier on, I want to be able to create kind of like animations at intervals. So the way I'm going to be separating the first animation over here from the second animation would be to check their index. That was why initially in the beginning of this video, I did an if statement to just check if the index is 0, do this. So this function is going to be making use of the indices to be able to differentiate each animation. And one thing to note here is that this animated builder wraps one actor. So there's an actor wrapping this, there's an animated builder wrapping this actor, there's another animated builder wrapping this actor, and so on and so forth. So the way they are going to be related is by having just one single animation controller, which is what we defined over here. So we'll be using that single animation controller to control everything, then offset them by their index. So I could head over to that DevTools and you just see what I'm actually talking about. So is it okay? I haven't saved. I don't want to save yet. If I save, I would show you what that actually means. You'd see that these actors are wrapped inside an animated builder. So I'll head over here and pass in the index as the arguments. So this function is going to need an index, and you can see currently it's complaining because we haven't returned an animation. So the first thing I want to do now would be to create some variables. So I'd say last actor starts time should be 0.3. Then actor animation duration should be 0.6. So remember what I told you, the value scales from 0 to 1. So the last actor start time, that means if the animation is going to be 1 second long, the last item over here, this last actor, is going to be starting at 0.3 seconds. And the actor animation duration, that is for individual actors, their duration is going to be lasting 0.6 seconds. So the reason I'm not putting 0.7 here, for instance, is when we do the calculation in the next line, you'd be able to see that sometimes the value might go up to 0.9 something. So it's always better to put it in the lower scale. Else, you're going to get an exception that the animation value is larger than 1.0. So I'll explain everything I'm doing as we progress. So we have the double. So the thing we want to achieve here is to create a tween animation. So a tween animation has a begin and an end value. We're going to be creating a tween animation and also pass in a curved animation. So I'm going to be able to, I just want to create the time at which the first item should start. So I'm going to do a bit of high school maths over here. So I'm going to do last actor start time multiplied by index over number of actors. So is this correct? Yes, it should be. So last actor start time multiplied by index all over number of actors. So for instance, now the first index is always at 0, right? So 0 divided by number of actors, which is currently 4. 0 divided by 4 is what? 0. Then 0 times what? Last actor start time is going to be equals to 0. So the first actor over here is going to start at frame 0. It's going to start at the very beginning. So I'm not going to be calculating for this. Let's just head over to the last one. So the last one is what? 3. The last index is going to be 3. 3 divided by 4 is 3 divided by 4 is 0.7 something. 0.7 something times the last actor start time is going to be what? 0.6. Let me just confirm. So 3 divided by 4, 0.75 times 0.3, 0.225. Cool. So this is correct. So let's just say 0.3. So approximately the last actor is going to start at 0.3 seconds, and it is going to, you can see it's even I've even defined it over here. It's going to start at 0.3 seconds and last for a duration of 0.6. So it's going to go from 0.3 to 0.9. Then the end of the animation would be, how I'm going to do this, the end of the animation would be actor animation duration plus begin. So actor animation duration. So if the duration of a particular animation is going to be 0.6 plus begin, okay, yeah, so that's correct. So the end of the animation is going to be the begin, which is what we just calculated here. For the last actor, for instance, is going to be at 0.3, right? It's going to start his animation at 0.3. So what we are doing here is 0.3 plus 0.6, which is 0.9. So the animation is going to progress from 0 from 0 to 0.9 and not 1. And the reason I'm stopping at 0.9 is because sometimes there could be additional decimal places. And if we had done 0.7 over here, it might be above 1. So I'm just keeping it safe by doing it from 0.3 to, and it's going to last for a duration of 0.6. So this is high school maths. So let's just continue. So I'm going to be returning a tween animation. It's tween animatable, not a tween animation. So the begin is going to be initial offsets, which is what we've declared over here. We've declared the initial offset to be 0 and the final offset to be 1.0. So we're going to be using a tween for this. Just calm down. You're going to see where I'm going to use this begin and end as we progress. So the begin is initial offset, and what's the second argument? The end is the what? Is it final offset? So that is the tween. And remember, if we put a semicolon here, it is still going to complain because this function expects you to return what? An animation. The animation that we're going to be using were inside this animated Buda. So lucky enough, we could just simply do something like dot animate. And this is where we now pass in the parent. So what is the parent here? The parent is going to be, let's see. The parent is going to be we're not going to make it linear. It's going to be a curved animation. It's going to be a curved animation. And we now pass in the parent. So the parent is going to be what? The loading animation controller. And what's the next? We're going to pass in a curve. So the curve we're going to be using here, like I explained earlier on in this video, is that we don't want everything to animate from 0 to 1. We don't want everything to animate together at the same time. Instead, we want to make them animate at intervals. So this first animated Buda would start his animation, while this other one starts at different intervals. So for the curve, you're going to be using something called an interval. An interval which takes in a begin and the end, and we've defined it over here. So you can see this logic we've created previously over here is going to be responsible for creating the intervals based on the index. Can you see we divided it by the index? So the animation for this guy will be different from the start time of this first actor would be different from the start time of this second actor to the third and the fourth actor. So that is just the basic structure. We can add a curve, but I'll leave that for now. We'll just, no need for the curve for now. Okay, cool. So I think we are good to go. So I'll just copy. Okay, I'll just init loading animation. Then we pass the animation to the animated Buda. So if we save, I think we would have to do a hot restart, but let's see. Parent not equals to null. Okay, let's do a hot restart and I'll read this error. Okay. So let's see why this is not playing. So we have init load animation. We've returned the animation over here. And Transform, translate. Okay, so yes, the animation would not play because we've not made use of this animation, because you can see over here what I told you guys about the animated builder. The animated builder is very good with transitions. You don't have to call set states. It doesn't have to know the widget you want to animate doesn't have to know about the animated builder. You just wrap the widget inside an animated builder and you pass in the animation you want it to play. And remember what I told you guys, the animation is going to be playing from, it's going to be in the range of 0.0 to 1.0. So over here, this animated builder has this animation, but we have not used it. So what we want to actually do is to pass it to this offset value. So we want to offset the value of the transform widget in the y-axis. So to do that, I'll just do something simple. I'll say minus 50. Doesn't matter if we put the 0. So minus 50 times animation dot what? Value. Oops, what did I do? Okay. So now this animation value, remember what I told you guys? It goes from 0 to 1. So at the very first frame, if it is 0, so animation.value, if it is 0, 0 times minus 50 is 0. So that is the starting point. And the ending point, if the animation is 1, we are now doing 1 times minus 50, which is minus 50. So what this stuff is going to be doing is that it is going to progress from minus 0 to minus 50. Let's just save it and you'll see what that looks like. But it is not, everything just goes straight forward. Why? Am I missing something? Minus 50 times animation.value. The animation value changes over a period of 1 second. If the animation is completed, then start it. And over here we called, okay. Let me do a hot restart and see. Oops, okay. So there's something we are not doing right. This shouldn't change anything, but single ticker provider state mixing. I wouldn't. So we can see the interval here. Okay guys, should I pause this video and come back? No, or should I solve it right in front of you? Let me do it in front of you. So if the animation status is completed, then you should start the animation all over again. We also have this. We've passed in the index, and this animation value is going to change. Is there something I'm missing? Initial offset, curve. Okay, I think I would have to quickly go and come back and solve this before, so I wouldn't waste your time. Okay, from the thing I noticed, over here we said the animation should play when it is completed, but we did not specify where it should start from, because if you can see this forward has a from argument. So when I do from 0, it means that when the animation completes, I want to start it from the 0 point, that is from the beginning. So let's see if that works. I'll do a hot restart. Okay, the animation is mm, the animation is playing right now. Mm, okay, let me add a curve. Curves does ease. And one more thing. Let me do a hot restart. Okay, so now we are good. But there's something I want you guys to notice. The problem with Tween over here, can you see the animation is actually, can you see there's a little bit of, there's an interval between when the first animation starts and when the last animation starts. But this is not the final point. This is not what we are actually going for. And the problem with this current animation is that the value goes from what? From 0 to 1. That means it goes from 0 to minus 50. So it goes from 0 to minus 50 at the end of the animation. Then what happens? It comes back to 0. So you can see this lag, this kind of like break when the animation gets to the end. So it goes up from 0 to minus 50, then it comes back to 0 to minus 50. This is not actually what we want, because that is how, why is this stuff here? Expected to find what am I missing? I think I'm missing one of this. Okay. Okay. So with the way Tween works currently, this is how Tween works. So we'll head over to the source code of Tween to see how Tween works. To show you that there's nothing wrong with this animation currently if we use Tween. But if you check Tween, the definition of Tween, let's go to the top. It's a linear interpolation between the beginning and ending value. So the Tween animation, the Tween animatable just goes from what? 0 to 1. Just like a linear graph. So I saved a page here. This is how a Tween animation goes. So you can see from this animation, if it's going to be lasting for a duration of 1 second, which is from 0 to 1, this is the value. So at 1 second, the value is going to go from 0 to what? 1. At the middle is going to be 0.5. So this is how the Tween animation works. It goes from 0 to 1, then back to 0 to 1. That's why you can see this stuff going from 0 to 1, 0, 1, and it comes back. So if we head over to the source code over here, you can see Tween extends what? Animatable. So if we head over to the source code over here, let's see how this Tween is created, because what I intend to do right now is to create our own custom Tween. I won't call it a Tween, but we'll create our own custom animatable, because you can see the using Tween does not really work for what we want to achieve. We don't want to go from 0 to 1. We instead want to do something different. But let me just show you how Tween works. You can see the begin and the end, which is what we are passing here, the begin and the end. Then we now have the transform function. The transform function is a function from the animatable class, and see what it does. If the ticker, I think T is the ticker, like for the animation controller, if T is equals to 0.0, remember I told you guys it goes from 0 to 1. If it is 0, return begin, right? If it is the end, that is 1.0, return end. Then in between, what should you return? This is what you should return. The end minus the beginning times the ticker plus the begin. So for instance, now if the end is 1 and the beginning is 0, that's 1 minus 0 times, if the ticker is at the beginning, is 0. So 0 plus 0 is equals to 0. So this function over here is just going to be returning the values at the intermediary point. So from this graph over here, this if else statement does what? If it is 0, return begin. If it is end, return end. So if it is 0, return 0. If it is what? If you are at this point, if you are at the point 1, return what? 1. But at the middle stage, you should do what? Return the individual values here. So if it is at this point, to return 0.2, 0.25, 0.5, 0.75, then if it is at this point, it should return 1. So that is what this function actually does. And you can see from this, the tween class, you can see the transform function goes linearly. So it goes from 0 to 1. So now the stuff we actually want to do for this animation is totally different. We want to do something different. We want at the middle point of the animation should be the maximum value. So if you see this graph over here, this is actually what we want to achieve. So let's say we are moving from this point to this point. So if I start at the beginning, the value should be 0, right? Then if I am at the middle, the value should be what? 1. Can you see 1 over here? If I am at the middle of the animation, I want you to be at the maximum point of the ticker. I want to be at the maximum point of the ticker. Then at the ending of the end of the animation, what do I want? I want to go to 0. So you can see this curve. It goes from top. It reaches the maximum point at the middle of the cycle. Then it goes back to 0. So if we apply this concept to our animation, what that simply would mean is that at 0.5 in our animation, that is when our animation is halfway through, it should be at the what? Maximum value. So you can see here, this is a sine graph, and a sine graph is kind of like, it signifies kind of like a wave-like form, like a vibrating string. You can see this diagram looks like a vibrating string. This is high school maths. So if you are thinking you are never going to use high school maths in programming, here you go. So it's kind of like the graph shows the graph that could be represented like a vibrating string. So it's, I don't want to go technical, but if you can understand what I just explained here, if I want to move from 0 to 1, if I want to go from 0 to this end, that is, I want to go to this from 0 to 1 over here. For me to get to 1, that would be the middle of my animation. So at the middle point of my animation, I want to be at the maximum value. So by the time the animation is completing, this ball would already be down. So it's going to be giving us something like a wave-like pattern. And you're going to be seeing when I do this animation, it's going to be looking like this graph. So if we head back to Flutter, the stuff we're going to be creating is going to be a bit different from this. We won't be using an if-else statement. We could use an if-else statement to actually do this, but since there's already a math function that could help us do this, why don't we do that? And that function is, can you see, a sine wave is also called a sinoid. So I'm not going to be creating a tween. Instead, I'll be creating a sinoid. So I'm going to create that class quickly and you see what I'm actually doing. Sinusoid, okay. And it extends animatable. Double because you remember what I told you, an animation controller goes from 0 to 1, 0.0 to 1.0. So that is it. So I'm going to be implementing the transform method. But before we do that, we'll create the class members. So the class members are double, and I'm going to be naming them what? Min and max. I won't name them begin and end because if I give them the name of begin and end, the animation does not end when the value, when it reaches that value. Instead, it is kind of like in between. So I'm going to make this way, and we can now do this. So I'm just going to go here and copy this function from the Tween class, and the value we want to actually affect is this particular value, this ticker value. We want to be able to affect it with what? This logic of having this type of value. So we don't want it to go from 0 to 1 from the beginning to end. Instead, we want to get the sine value. So we're going to be using sine. I'll still come back and explain this. So I'm going to be changing this to mean and max. Yeah. And what am I going to do? I'm going to be, instead of having t directly, I'm going to be doing math.sine, and it is going to be in radians. Okay, math.pi times t, and I'll explain why this. So instead of this, I'll comment this. I'll still explain all this code I'm actually writing. So I'll change it to what? Mean and what? Max. So when I save this and I do a hot restart, okay, no need for a hot restart. You can see this is the oh my gosh. Why is this stuff breaking? This is the animation we want to achieve. So let me see. Okay, cool. You can see the flow of the animation here. Can you see? This is the animation we actually want to achieve. So back to this maths over here. So for those of you that think you would use maths, this is whole maths right here up in your face. So over here, this previous function is still the same thing. This part of this equation is still the same thing from the Tween, but instead we want to just affect the ticker value, because from here, from the Tween class over here, the ticker value is just going to be what? From 0.0 to 0.1 to 0.2 to 0.3 up until 1.0. But now what that simply means is that this ticker value at the beginning of the animation would be 0, then at the end it will be 1, just like this graph. At the beginning it's 0, at the end is what? 1. I'm using it on the, I'm getting the value from the y-axis over here. X, if you do your high school math, function x, when you pass in the value, y is going to be the result. So at the beginning, the ticker is 0. Then when it gets to 1, when it goes and gets to 1, the ticker value is 1. This is linear, and this is not what we actually want. What we actually want here is, you can see, so from this and from this equation, everything here is okay. We want to make use of this. We only want to just affect this guy over here. We want to transform it from going from this linear flow into a what? A sine wave. Is that the word? Yeah. We want it to have a sine wave format. So at the beginning, you can see it is 0 on the y-axis. Then when it completes one, when it completes 1 degree, as in 180 degree, because over here we are using pi over here. So when the length, this stuff is called, okay, the height is called wavelength. Yes, okay, amplitude, then this is called wave. Oh, I'm remembering high school math. Okay, let's get serious. So when it comes at the beginning of the animation, it should be 0. When it goes to the middle of the animation over here, what should be the value? It should be what? 1. And remember, 1 is the max value from the equation we wrote in our code. So I come again. At the beginning, it's 0. At the middle of our animation, what should it be? It should be 1. At the end of our animation, which is at this end over here, what should it be? It should be 0. So you can see that is why we are having this stuff. The time this actor gets to the topmost position, which is here, when it gets to this topmost position, which is here, that is the middle of the animation. Then when it now goes to the end of the animation, it should come back to what? 0. So that is why we are having this wave-like format. And you can see, if you look at the movement of this loading animation, it's a bit similar to this. So that is why I named it the Sinoid animatable class. So now the next question you might be asking is, why am I using pi over here? And let's go back to our code. If you see from our code over here, let me just see. So pi is, your equation is, the value of your equation is 0 whenever you get to pi, right? Okay, let me use this one to explain it. The sine of pi is equals to what? Let's see. Am I actually doing this stuff correctly? Okay, math.pi t. Okay. Okay, yes. The sine of pi is equals to what? 0. Then the sine of what? Pi divided by 2 is equals to what? 1. So if the if sine of pi is equals to 0 over here, so what we are doing here, let me just do this. T at point 0 is what? T at point 0 is what? 0 times math.pi is equals to 0. Then sine 0 is equals to what? Sine 0 is equals to 0. Can you see? So at this point is 0. So let's do for the middle stage. So if t is equals to 0.5, 0.5 times math.pi, so 0.5 times 3.142 would give us half of that particular value, if you know your high school math. So 0.5 times pi will give us half of pi. So what is sine half of pi? Sine half of pi is what? 1. So that means at the midpoint of our animation, the value of this guy is going to be 1. So you can see pi divided by 2 is over here. Pi divided by 2 is what? Because at the middle of our animation is 0.5, but here we are saying pi divided by 2 should be equals to what? 1. That is why we have this stuff go from 0 at the middle, it goes to the maximum value, then at the end of the animation, it decelerates back to the initial value. I'm trying so hard to explain high school maths here, but that is just how this stuff works, and I hope you get a hang of it, and when Tween might not be the best option for you. So to have this type of animation whereby you want it to go and come back to the initial point, you create a custom animatable such like this sinusoid. So that'll be it for this basic example. This example might be boring, but you just see how we can be able to translate this stuff into cool and amazing animations. So cool. So the next thing I want to do, we are done with this animation, right? Although it looks, this might not be the best loading animation in the world, but you could tweak it and do some other stuffs you want with it. Okay, so now moving on. Remember I told you guys that with this technique, we can be able to create infinite amount of animations, and I'll be doing that very, very quickly. So first of all, before we do that, let's do a brief recap. So we have an actor, which is just these individual circles. You can pass in whichever thing you want. Then we have the what? The loading animation, which is a stateful widget. Why are we making it a stateful widget? Because we want to do what? Mount our animation controller and play it, and also dispose the animation controller when the component unmounts. This is done to prevent memory leaks. So we also created some class fields over here. The number of actors, initial offsets, and the final offset. This initial offset is for the transform widgets. So I can set it to 1.0 and these elements should bounce a bit higher, and you can see they go much more higher than 0.7. So I don't want it to get to minus okay, we could leave it like this, but I think I prefer 0.7. So that's just it. Then we created an animation controller, which is just going to be responsible for creating our animations. Then we also created the init loading animation controller. What does it do? It initializes our animation controller and it sets up a status listener. Once the animation is complete, start it all over again from the beginning. And that is how that part works. Then the build method is very straightforward. It generates a number of actors. Then these actors, individual, okay, each of them are wrapped inside an animated builder. So each individual actor, each individual circle is wrapped in an animated builder. And if I come over here to my, okay, it refreshed. So you can see each individual actor is wrapped inside the animated builder. And the animated builder helps you to be able to create animations without calling your set state, and they don't have to know about the children. Instead, the children doesn't have to be responsible for controlling the animation. Instead, you just wrap it with an animated builder and it goes through your transition. So the value I'm going to be changing is the value that we are going to be transforming is what? The translates offset on the y-axis. That is why I'm multiplying this guy with the animation value. So that is just how this works. Then the init loading animation, I've explained the logic of having this initial, the last actor start time, and the duration. So this is basically how this works. You just go through it and with time you get a hang of it. So now back to the promise I made of creating infinite amount of animations. The first one we're going to be doing would be to we could, instead of using transform.translate, we could do something else. We could do transform.what? Scale. And instead of offsets, what should we do? Ooh, okay, what am I doing? So instead of the offsets for scale, what does it need? Let's check. Okay, for scale, it needs scale. And this loading ball is the first iteration. So for scale, what do we need to scale? Let's just copy animation.value and see how it looks. Let's see how you look. Can you see? Isn't that lovely? So you can see now with the same setup, we just changed the type of transformation. So now instead of having the circle bouncing up and transforming on the y-axis, we are just scaling the values by using transform.scale. And you can see how smooth it is. So the next one I'm going to be showing you is I could also use Let me see. I could also use return opacity. I could also animate based on opacity. Opacity should be what? Animation.value, because opacity ranges from 0.0 to 1.0 and it's in line with our animation value. Then the child should be what? The child should be the child from the animated Buda. Then we put a semicolon. And let's see how that looks. Can you see? This is also a loading animation. You can see how that looks just by changing the content inside this animated Buda. This is another variation of the loading animation. And the next one I'll be showing you guys would be transform dot what? Rotates. Transform does rotate, and it doesn't take scale. Instead, it takes what? It takes angle, right? So for the angle, I'm going to be doing animation value times math.pi. Math.pi, always remember that it translates to 180 degrees. You can see that from here. Oh, you can you see pi is equivalent to 180 degrees in degrees. So I'm just going to do math.pi 180 degrees divided by 2. That's 90 degrees. So at the beginning, it should go from 0 degrees up onto 90 degrees. So I'm going to do math.pi divided by 2. But watch what happens. We are not going to be able to see this. And I want you guys to guess why before I continue. We're not going to be seeing the rotation. Do you know why? Because these are circles. So it's actually rotating, but you won't be able to see it. So to change that, you could just come over here and change box shape dot what? Box shape dot rectangle. There might be an overflow. Can you see they're actually rotating? So for the width, I'm going to reduce the size divided by 2. I want to create kind of like a domino effect. Okay. Then can you see the axis at which they rotate? They rotate from the alignment is at the center, but I want to change that. We'll change that in a jiffy. So the width, let me reduce the width to 80, because now 20 divided by 2 is 10. So they are 10, 10, 10, 10 times 4, 40, individual, inside 30, 40 plus 30, 70. Then I'm just giving it some extra space. So the width 80 from 100. Then the next thing I want to do is to change the alignment. Currently, they are rotating from the middle point. So I want to change the alignment to alignment dot bottom right. Let's see how that looks. Can you see? Are they actually hitting? Oops. Okay, but you get the idea. You could always tweak this stuff. You can see how we are just creating variations of animations here. You could actually tweak the spaces in between them and delay them a little bit. So when this first guy hits, can you see the first guy hits the second one to the third one, the fourth one, and you can see how we are creating multiple variations of this type of animation just by changing this stuff. So with this idea, you could be able to create let me see, top center. So you can see with the base logic, it's not going the direction I want. Okay, but you guys can tweak all those stuff. You can tweak it, tweak it, tweak it. So let me go scale. So you can even mix scaling with rotation to create multiple kind of like chaining your animation. Okay, okay. So I'd want you guys to just play around with this and see different ways you can actually create multiple variations of this animation. So you can see this type of loading animation. We could actually increase the height. Can we increase the height? Size times 0.5. And reduce the width. You can see I'm just playing around and you can see different types of this variation. But first of all, like, if you guys like hanged on for this video up until this point, like, kudos, thank you for staying with me up until this point, because I know this video is already long and if you were not patient, you wouldn't be able to get it up to this point, because I ought to have recorded kind of like a GIF or a short video to show you what I intend creating at the beginning of this video. So I think we've come to a very comfortable place, and thank you so much for watching. Is there something I'm missing? I don't think I'm missing anything. So with the knowledge of this stuff, I believe you can be able to create any type of animation you see. This stuff is like super easy to actually create. And one more thing before I even show you guys this stuff, one more thing, you can actually add a text beneath this stuff. I'm not going to be doing that in this where's the build method? In this build method, you could convert this guy to wrap it in a column and add a loading text animation. So you just create the same thing with this animated builder. So instead of the builder returning a transform, the builder will be returning what? A text, probably wrapped in an opacity. Then you now pass in the loading animation controller value. Then underneath this loading animation, you'd have the text also showing, kind of like fading in and fading out. I would leave you guys to play around with that and see the cool stuff you guys come up with. So this type of animations are very, very easy. So with the interval stuff that we did, so probably if the animation is from 0 to 1, at 0.7 you should do what? Reduce the height of the circle and increase the width. So that gives you this squashing effect. So there are lots. This one, let me see. That's your assignment. Okay, so that's just the whole idea of this video. This is something similar to the first one we've created, but you just have to find a way to tweak it. So I believe I've done justice in this video, and I hope you've learned something. If you need any further clarifications, do drop a comment, and don't forget to like the video, share, and subscribe if you haven't. So I'll see you guys in the next one. Bye.